dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Assalamu alaikum warahmatullahi wabarakatuh. Welcome from trees. This is our first lesson about parabolas. Today we will do more examples about parabola, how to find the equation of a parabola with center h, k. Okay. This is summary about the standard equations of a parabola. If we are given the vertex at a point which is different from the center, which is h, k. This is the center of each and every parabola that we will be given the descriptions of those parabola from here. Look here. If this is equation, it has y has a power of 2. Therefore, as long as the power is on y, it means that our parabola will be, the axis of symmetry will be horizontal. Either it will concave left side or right side. Okay, as long as here is positive, it goes right side. If it is negative, it concaves left side. The axis of symmetry is always k. That will be the axis of symmetry. The axis of symmetry, in this case, our parabola, it goes h and k. Suppose this is h, k, which is the vertex. The axis of symmetry, as long as it is horizontal. 4b, that's positive, therefore it will concave to the right side. That will be our parabola. Look, the focus. The focus, it goes, if here is the vertex, the focus is kp units to the right side of the vertex. Therefore, it goes to h plus b, k. As long as we have a horizontal line, the only thing that changes is x values. Y will always be the same. Look here. For the focus, it has k. For the axis of symmetry, it has k. Also, the vertex, it has k. But the only thing that we are going to change is the x values because it is horizontal. Okay, that is the equation of a parabola. This is the focus, the directrix. If we want to find the end of latus rectum, it doesn't make it is only thing that is a line which passes through the focus and perpendicular to the axis of symmetry. Therefore, the end points we can find, we have here b value and 0. Therefore, in order to find the end points of a latus rectum, you can substitute the equation to b, then you will get 2 values for y. Then you can get 2 values for y. This is the equation of a parabola which concave is up or down. Here is the focus, the directrix, and the end points of the latus rectum. Okay, let us continue. Let us continue. Here we have, this is example 1. This example we are given some information about the required parabola. We are asked to find the equation of a parabola whose focus, therefore we are given the focus as 5, 3. And also we are given the equation of the directrix, First, let us see the concavity of this parabola. As long as we have the directrix as x equals -1, it means that we have a vertical line. If the directrix is vertical line, then our parabola will concave right side or left side. If the directrix is a horizontal line, which is y equals something, it concaves up or down. Therefore, this one, the equation takes the form y minus k power 2 equals 4p into x minus h. But let us write, what are we given here? We are given the focus as 5, 3. Also, we are given the directrix as x equals -1. Let us draw illustrated diagram. We can find the value of x. Look. Okay. It is known that the distance between distance between the focus and the vertex, it is B. Also, the distance between the vertex and the directrix is always P. Therefore, in this case, we have the focus and the directrix. Look, this one. This is our parabola. We are given the focus as 5,3. 5,3. If here is 5, let us move up somewhere here. It is 3. That is 5,3 the focus. Therefore, it has horizontal axis of symmetry. It has horizontal axis of symmetry. Our directrix goes as minus. It is -1. X equals -1. That is the directrix. What we are supposed to find first, can we get the vertex? The vertex, yes, we can get the vertex. Look, the distance between this line to the focus, it is 2p. It is twice of p. Let us find the change of x from the directrix to the focus. X is 5 and here x is -1. Therefore, the value of 2b, it is 5 minus -1. Therefore, 2b is the same as 6. The value of p is 3 because this 2b comes from the distance between the directrix to the focus. Therefore, the value of p is 3. If p is 3, the vertex will go 3 units left side of the focus. Therefore, 5 minus 3, it is 2. Therefore, somewhere here is 2,3. Our parabola concaves to the direction of the focus. Therefore, look, we have here the focus. The vertex, it has coordinates of 5 take away 3. It is 2,3. The only thing that we are not changing is 3, which is k, the value of k. This is h, and this is the value of k. Therefore, the equation, we will substitute y, value of k is 3 squared, for the value of p is 3, I guess the value of h is 5. Sorry, 2. It is 2. It is 2. The value of p is 2. That's -2. That is -2. That's -2. That is -2. Sorry. Okay, that's -2. Therefore, we can simplify. We can simplify. Let us simplify this one. Y -3 square, it is 12 into x -2. This is the standard form for the equation of this parabola. We can proceed by expanding this part and this part. Then we can give the solution as a general form. Let us go back to some explanations about this question. We are given the focus and the directrix. Bear in mind, if the directrix is x equals a number, it is a vertical line. If it is a vertical line, it is obvious that our parabola will face to right side or left side. Okay. To find let's first find the value of p. To find the value of p, the distance between, okay, the only thing that will change is the x values, and always y will always be constant. The value of k from the vertex doesn't change. Okay, therefore the k is always 3. It will be 3, but let us find the value of h. To find the value of h, it is better to find the value of p. The only way that we can find the value of p is that it is known that the distance between the focus and the directrix is twice of p. It is twice of p. This 2b comes from the distance between the directrix and the vertex is p units. The distance between the focus and the distance between the vertex and the focus is p units. That is 2p. Therefore, 2b comes from 5 minus -1, which is the directrix. Therefore, the value of p is 3. If the value of p is 3, the focus has a value, x value as 5. Then if we go back 3 units from 5, it is 2,3. Therefore, we have the vertex as 2,3. This is h and k. As long as we have h and k and b, we can find the value, the equation of the parabola, but simply by substituting values of k, p, and h. K is 3, y -3. squared. 4 times b x minus 2. Therefore, this is our standard equation. Then let us write it in general form. If you square this one, you have y squared 2y times 2, the formula for binomial expansion, that's 6y. 3 squared is 9. This equals 12 times x. It is 12x. 12 times that's 24. If you rearrange this equation, you have this form: y squared minus 6y, taking 12 to the other side, it goes to minus 12x. Therefore, minus 24 taken to, if we take to the other side, it takes positive. Then 24 plus 9, we have 33 equally 0. That is the general equation of this parabola. This is the general equation of our parabola. I think it is very visible. Therefore, this example is from 3 Somaliland, from 3 book. Okay, let us proceed. Okay. Okay, let us do it again, that question, because it seems a little bit complicated. The previous one. Okay, for the previous one, we were given as 5,3 for the focus, and the directrix as x minus 1. If the previous method is a little bit difficult, you can proceed like this. First, draw a rough sketch. Rough sketch. The focus is 5,3. If here is 5, look, we call this point as 5 and this point as 3. Move up. It is here 5,3. That is the focus. As long as our directrix is minus 1, it passes through here. It passes through here. That's the directrix. X equals minus 1. Therefore, if the directrix is this way, then our parabola will concave to the right side. To the right side. Therefore, somewhere here will be our vertex. Therefore, the coordinates of the vertex, it is obvious that always y will be 3. You have 3 as k, but we don't have the value of h. To find the value of h, simply we find the distance between the directrix and the focus. That is 2b. 2b is 5 minus 1. 2b is 6. If we divide this side by 2, the value of p is 6 divided by 2, which is 3. If we have the value of p, if it is 3, the vertex, it is 3 units left side of the focus. Therefore, 5, take away 3, you will get 2. Our vertex has the coordinates of 2, 3. Therefore, as long as we have the coordinates of the vertex, our equation, it takes the form, y minus k power 2 for p x minus h. Let us substitute the letters. What is the value of k? It is, that one is k and this one is h. That is k and this is h. Y minus 3 square, it is 4 times. What is the value of p? It is 3. X minus the value of h, which is 2. Let us simplify. Here we have y minus 3 power 2. It is 12 into x minus 24, because we should remove the bracket. Sorry, 12 minus 2. 12 minus x minus 2, sorry, x minus 2. That is x minus 2. That is x minus 2. Then we will remove the brackets from both sides. Y minus 3 squared. If you expand y minus 3, you have y squared minus 6y plus 9. Expanding the other side, we have 12x minus 24. Rearranging the letters, taking all the letters to terms to this side and equating to 0. We have y squared minus 6y. If we take 12x to this side, we have minus 12x Taking 24 to the other side, it takes positive. 24 plus 9, it is 33. Here we have equally 0. This is our general equation for the parabola. Therefore, this one is general equation. And here we have the standard equation. We have the standard equation. Okay, tomorrow we will continue from here. Then we will stop here. Assalamu alaikum wa rahmatullahi wa barakatuh.